Yeah, those are fun too. The random haunted houses in the neighborhood, that's fun. Yeah. Yeah. Halloween's a lot of fun. I like it. All right. So we have two more sections to cover. We're going to cover expected value and odds. Now, good news is both those topics use probability. Okay. So we're just going to learn a new way to use probability. Anybody have any questions on probability before we start talking about the new topic? All right, so let me give you an idea about expected value. I know some of you have already started the homework. That's awesome. That's great. Let's talk about what expected value is for just a moment. There are lots of games of chance. There are lots of things that people do for fun. They bet with. Um, and I don't mean like the illegal gambling going on in the NBA right now. And I don't mean like wearing the glasses so you can actually see through the cards and you can see the backside of the card and know what's being played. Not talking about that. Talking about real legal gambling. And people go and they know ahead of time. Okay, we know ahead of time what our odds are of winning the game. If we know what the odds are, we know what the expected value is, and we know what the probability is. We know whether or not we want to choose to play. Okay, so we are going to actually calculate the expected value. So it could be for a game of chance. It could be for a business. In other words, a business could know the expected value of a bid they put out. They could say, okay, we know that we get so many such a percentage of a bid. If we put the bid out here, what's the probability we get it? What's the expected value that we get the bid? So forth. So expected value is very, very useful. And believe me, that's how all casinos make their money, is they know the expected value of the game before the game is ever played by anyone. So they know right up front, this is what we're going to be paying out, and we don't care. All right. And like I said, a lot of you have already started it. That's fantastic. All right. So let's look at this game. We have a game costs $2 to play. In the game, the player picks a card at random from a standard deck of cards. If the card is a face card, the player receives $7. If the card is not a face card, the player receives nothing. In other words, they lose $2. Okay. So expected value is a formula. Let's write the formula down. The formula is a function that we call E of X. So E of X, the expected value of an event X is the first event times the probability of that event plus the second event times the probability of that event. And you could have as many of those different events in there as you want to. Okay. I'm just using two because our example is a win lose, right? Gain. I'm going to use gain or lose. So the expected value we're looking for here, and this one is we have a gain, right? What do we get? We have a gain where we receive money. So we have a gain times the probability of that gain. Plus, we have a loss times the probability of that loss. While you guys are jotting that down, I'll go to Desmos and I will get the calculator for expected value. It's already in. If you look in the announcements, it's already there. If you've been doing the homework, it's already there. All right, so it's there. You just have to go and grab it out of the announcement. I'll pull it up here as well. All right, so there's a link to what I'm using right now. All right, and I'm gonna erase some of these as we go. I don't need all of them. So let's go back up here to our question. The question is, it costs $2 to play. Okay. So everybody, If I win the game, how much do I gain? That's the question. If I win, how much do I gain? Do I gain $7? Not how much do I win, how much do I gain? Right, I gain $5. So the expected value of this game of chance is 7 minus 2, that's the gain, times the probability that I have a gain. In other words, that I win. What's the probability up here? If the card is a face card, I receive $7. Everybody, what's the probability that I get a face card? This is from last week. How many face cards are there? 3 in each suit, right? 3, 6, 9, 12. So there are 12 out of 52 face cards. Plus, exactly, Norma. I'm sorry about that, Sarah. Hopefully it works for you. If I lose, how much do I lose? It's a negative $2, right? It costs $2 to play the game. What's the probability that I lose? It's 1 minus 12 over 52, right? Which is 40 over 52. That's the expected value of this game. Now, let's just take this information and put it directly into Desmos, okay? Let Desmos do the work for us. All right? So you can see I have that right here, everybody. It's precisely the third one up from the bottom here. No, it's 7. I'm sorry. It's 7. So let's go up here. Let's put in 7. $7 minus $2. The probability is 12 over 52. If I lose, it's negative $2. And the probability is 40 over 52. The expected value is negative 38 cents. Okay, that's my expected value. So in the long run, now everybody, that's from the player's perspective, the player. So that's equals to negative 38 cents. This is a dollar, so write it in as a dollar amount. Negative 38 cents. What does that mean? That's from the player's perspective. So that means from the player's perspective, on average, they're going to lose 38 cents. Okay. Now, obviously, nobody's going to lose 38 cents, are they? Right? They're going to lose $2 or they're going to gain 5. But if the average is losing 38 cents, what's that telling you? That tells you that way more people lose than win, right? Way more lose than win. And from the person who owns the game, they say what? They say, yeah, come play. Come on. Come on. Every time you play the game, I expect to win what? 38 cents. Who wouldn't want to play that game, right? Who wouldn't want to own that game? If every time a person played, you knew that you were going to win 38 cents, you'd say, line them up, right? Come on in, everybody. If I can get 100 people to play, I just made 38 bucks, right? If I can get 1,000 people to play, I made 380 bucks. So they want everybody to play because they know on average, for every person that plays, they win 38 cents. Once again, that's from the perspective of the game owner. From the perspective of the player, they lose 38 cents. That's exactly how casinos make their money, Elaine. They know for whatever game you play what the expected value is. And they don't care if they give the person who's sitting there in front of you $5,000. They could care less because they know on average, every person that sits down at that game, they're going to make 5, 10, 15, $20. They know what the expected value is. So they love to make a big deal out of, oh, somebody won. Woo-hoo. Yeah. Well, before that, about 1,000 people lost. That's called expected value. And that's exactly how they make their money. They know exactly up front what the expected value is for every single game that they have. All right. If you haven't tried this question yet, everybody go ahead and try it for yourself. Now, I see 4 of you have already gotten it correct. That's fantastic. Congrats to you guys. If you've already done it, just keep going on with another one. If you haven't attempted a homework question yet, jump in and try it. Use the Desmos calculator if you like. You don't have to, but you may use it if you like. Now down here, when you get to this part, we found out that it was a negative amount. It says, this is not a good game to play because the player will tend to lose money. That's exactly what we saw. We saw you're going to lose money. Okay, so every time you come to one of these, everybody, write down your equation, your expected value in terms of gain, gain, and loss. Gain and loss, not win and lose, gain and loss. And write the formula out so that you don't have to be surprised.
Confused by number 2.
All right, number 2. A certain game, a player picks a card at random from a standard deck of cards. If the card is a heart, the player wins $10. Otherwise, the player loses 5. What's the expected value of this game for the player? Okay, for the player. That's the perspective. So our expected value, E of X, is equal to the gain times the probability of that gain plus the loss times the probability of that loss. All right, if they gain, how much do they gain? A player picks a card at random. If the card is a heart, the player wins $10. Otherwise, the player loses 5. Do they gain $5 or do they gain $10? It doesn't say it costs anything to play, does it? It doesn't say that. All right, so let's try it. Let's try it. Let's say they gain $10. What's the probability they gain $10? They have a heart, right? If they get a heart, they win $10. So what's the probability you get a heart? 13, right? 13 out of 52. All right. If they don't get that, they lose $5. So -5 times the probability they do not get a heart is what? 39 out of 52. Let's see if that's correct. Sometimes these can be tricky because they're not always clear. All right. So let's try it. All right. $10 times 13 divided by 52. All right. Minus $5 times 39 divided by 52. Oh, this is wrong over here. My bad. Got a typo here. It says I have an expected value of negative $1.25. Negative 125. All right, let's see if we did this correctly. All right, that is correct.
So what I was stuck on is I put 10 minus 5 in that equation to make it 5 instead of the 10. So when they don't come and tell you that there is a buy-in or
Right.
whatever you have to put down, then you just
Yeah.
put whatever that profit is going to be.
Yeah.
Okay.
Yeah. This one didn't have a buy-in. The other one had a buy-in. This one does not. All right, just take a few minutes and work on some more. I'll be quiet and let you guys work. Remember, always set up the equation with gain and loss. Like Ashley just said, that's the tricky part, knowing what the gain and the loss is. Now you can see this one has more, right? This one has more events going on. It doesn't have just two. Notice down here on this one, everybody, I put three events. X3, the probability of X3, X4, probability of X4, X5, probability of X5. So there's actually three events down here, and you can add more to it if you want to. Yes,
Okay, I had a quick question. I was watching you do the question with Ashley and I looking at the chart now, where did you get the 39 from? Like I understand everything else, but for the 39 over 52, where did the how did you get the 39?
that is 52 minus 13.
52 minus 13?
Yes, in other words, there are 13 hearts,
Mm-hmm.
which means there are 39, 52 minus 13 that are not a heart.
Mm-hmm. Oh, okay. Okay, thank you.
Yep. Don't be confused by the game, everybody. Don't be confused by the games being different. Just be sure you have the perspective from the player or the owner of the game, like when we get down to life insurance. So for everyone, make sure you have the correct perspective.
Stuck on three. My brain is not understanding. I'm sorry.
Don't apologize ever. Remember that? Who did I tell that to? Jenny. I said, Jenny, don't ever apologize. A game costs $10 to play. In the game, there's a bag that contains 24 balls. 10 are red, 7 are green, 7 are yellow. The player of the game draws one ball at random from the bag, and the player wins $10. If they draw a red ball, oh, $10 if they draw a red ball, nothing if they draw a green ball, and 19 if they draw a yellow ball. What is the expected value? It costs $10 to play. All right, so let's write it down together. All right, start with the first one. What's the first event? Okay, we know there are 24 balls, 10, 7, and 7. All right, what's the first event? They win $10 if they draw a red ball. So how much do they gain, everybody? Zero, exactly. So the first one is 10 minus 10. What's the probability they get a red ball? There are 10 out of 24. All right, plus this is red. All right, what's next? Green. If they draw a green ball, They get nothing. Okay, it costs $10 to play, so that's 7 minus 10 times 7 over 24. This is green.
Wait,
All right.
I'm so sorry. Where did you get the 7 minus 10? Is it because there are 7 green balls? Because you get
Oh, wait,
nothing.
that's 0. That's 0, not 7.
Okay.
Yeah, good catch. They don't win anything. They win nothing. That's 0. So 0 minus 10 times 7 over 24. All right. Plus, if they draw a yellow, they win 19. 19 minus 10 times 7 over 24. All right, so you can put that wherever you want to down here if you're using that calculator. You can't put it up here because there are only 2 events up here. You can put it down here in this one where there are 3 events. All right, you can put it right there. And you can see right here, it's already part of it is there. So right here, you could put 0. And the probability is 10 divided by 24. All right, the next one is -10. The probability is 7 over 24. The next one is 9 is what I gain. And the probability is 7 over 24. And the expected value is -29 cents. Right here in the end. If you want to, you could always round this off to make it look like a numerical value, right? So right here, I could do round. Whoops. You got number 5. Good. My wife was asking me the other day about roulette. She was asking me about the game with the best expected value. And this is it right here. The game with the best expected value is roulette. If you bet it correctly. If you bet it correctly, it's the highest expected value that you will win. Let's look at a roulette wheel. The American roulette wheel has 38 spaces. If a player wins, they keep their bet. They keep the bet. Okay. Suppose that a $9 bet is placed on a single space with $315. Wins. If the space is landed on, otherwise the player wins nothing. What is the expected value of the bet from the casino standpoint Round your answer to the nearest cent. All right, so now, if I do the expected value this time, the win and lose is from the casino's perspective. So expected value equals gain. This is from the casino, right? Times the probability of gain plus loss times the probability of loss. And again, this is from the casino's perspective. So when does the casino gain? The casino gains if the wheel loses, right? So the casino gains $9, right? $9 is bet on a single spin. So they gain $9. All right. What's the probability that they win? In other words, what's the probability the person lose? There are 38 spaces. They're betting on one. So there's 37, right? 37 out of 38 is the probability that the person loses. The casino wins. All right. How does the casino lose? The casino loses if the person lands on one space. All right. If the person lands on that one space, if they do, they get $315 and they keep their $9 bet. If the player wins, they keep their bet. Okay. And they win $315. So $315 total. What's the probability that happens? 1 out of 38. And again, this is from the perspective of the casino. The casino gains $9 if the player loses. They lose $315 if the player wins. They don't lose the $9 bet. That's neither here nor there. They had it and they gave it back. That's a draw. That's another thing you got to be careful of, everybody. If you hear somebody say, if you hear somebody's gone to the casino and they've been playing those games and they come back and they say, I won $100 at the casino tonight. I'm so excited. Always ask them what? Ask them, how much did you play? How much did you pay? Did you win $100? Did you gain $100? Did you pay out 400 and came home with 100? Right? That's not a gain. So that's why the gain is always the only thing that matters. Don't get excited if you win some money if you already paid way more than that. Break even, yeah. Well, you're way ahead of most people. The casino wouldn't be open if everybody was like you, right? The casino only stays open because the majority of people lose. Otherwise, there'd be no casino. They'd have no reason to be there. All right, let's go down and talk about a life insurance question. Suppose the probability of a certain 22-year-old person dying within a year is 0.001215. They're offered a $150,000 life insurance policy for that year. The policy comes at a one-time cost of $325. What is the expected value from the standpoint of the insurance company? Now I'm going to show you guys something interesting, okay? And this one says, all right, let's start with this one. First of all, it says from the perspective of the insurance policy, I'm going to do it from the perspective of the insurance holder, not the company, the holder of the policy, okay? So once again, gain times the probability of gain plus the loss, whatever that is, times the probability of that loss. How does a person gain, everybody? A person gains only if they die. You with me there? You gain if they die. It costs them $325 for the policy. And if they die, they're offered $150,000. So the gain would be $150,000 minus $325. What's the probability that they don't die, right? The probability of this is the probability they die. It's 0.001215. All right. If they lose, if the person loses, they lose the $325. In other words, they live, right? They live. They paid $325. They didn't die, so nobody gains the profit from it. So what's the probability that they die? I'm sorry, what's the probability they live, rather? It's 1 minus 0.001215. So in this case, they gain if they die. If they don't die, they lose the money. That doesn't sound like a very good win, does it? All right, so let's go right back up here. And let's go in here. And let's put in 150,000 minus 325. And the probability of that is 0.001215. All right, the next one is negative 325. And the probability is 1 minus 0.001215. All right, the expected value is negative $142. Now, everybody, listen carefully. You get both answers to both questions at one time if you're just aware of the fact. This was from the policyholder's point of view. In other words, on a value, on average, they expect to live, therefore they expect to lose on average negative $142.75. The person buying the policy expects to lose the money because they expect to live. Does that make sense? So from the insurance policy holder, from the policy owner, they expect to make $142.75. So right here, they expect to make $142.75. The insurance policy holders are going to earn $142.75 every year for every person that buys that insurance policy. And the vast majority, well, just look, everybody. If you're an insurance company, if you know that every single policy you sell, you earn $142.75, are you afraid of losing money? No, you're not losing money. Every single person that signs on that dotted line, you just earned $172 for. I'm $142. All right. First of all, let's check our answer and make sure we're right. Okay, we're right with that one. Now let's go to the next part of it. It says, what should the company charge if they would like to have an expected value of $100? They already have an expected value of $142, but they want $100 for every single person. So this one's a little bit trickier. So watch my calculator here. All right. I'm going to take this equation right here. And the question is, how much should they charge? I'm going to take this equation, and in place of 325, I'm going to put X, okay? And I'm going to set it equal to 100. So right here, I would put 100 equals 150,000, whoops, 150,000 minus X, put it in parentheses, all right, times 0.0, let's get the right numbers in here. 1215 plus negative X times 1 minus all right, now you say, I don't see the answer anywhere. Let's go check and see if we can see the answer anywhere. It's going to be a red. And it says over here, it says it's a negative amount. So we're looking at it from the perspective of the buyer. So that would be a positive amount. When we put an answer in, it's $81, $81.78. That's what it says right there, 81.78 if I round it off. I'm looking for this vertical line. In other words, I'm solving the equation for X. Let me put this in a different perspective, okay? So we have it from a better perspective. Let me do that for you guys. This is the correct answer. Let's turn it around the other way from the insurance company's perspective, okay? Let's turn it around. I think it'll be easier for you guys. We should come up with the same value. So expected value from the insurance company's perspective. All right, they gain if the person lives. So the gain is what? The gain is $325 times 1 minus 0.001215. This is the gain. They lose, right? How much do they lose? They lose $150,000 minus $325. And the probability of that is 0.001215. That's from the insurance company's perspective. Let's check and make sure we're correct, okay? Notice I just changed the probabilities around. That's all I did. Let's try it. Okay, so the first one was $325 times 1 minus 0.00125. The next one is $150,000 minus 325 times and there it is. $142.75. That will make it actually easier for us when we come down here below. Now, when I come down here, everybody, to put it in this equation right here, I would put 100. Now watch, I'm gonna match this line right here. I'm gonna match this line by simply putting in X in place of 325, okay? So in place of 325, I'm gonna put X. So X times 1 minus 0.001215 plus I got to change this up here. Plus, what I put in here? 150,000 minus 325 times a negative 0.00125. If I made this positive right here, let's see, if I made this positive, I'd have to turn this around up here. So I could also do this. I could put 325 minus 150,000 to make my probability positive. So up here, if I put, I'm trying to set this up for you guys so I can share it with you and you can just use it. Minus 150,000 and make this positive. Okay, so watch what I did. I took this value in place of 325, I put X. I just put 1 minus that probability right there, plus 325 minus, this is supposed to be a minus. This is X. In place of 325, I put X, and there's a probability. I can go over here and look on my graph. And it's going to be $282.25. $282.25. And that's what I would put in here, 282.25. If you don't like using Desmos to solve the equation for you, you can solve it by hand if you prefer.
Could you share that? Oh, thank you.
Yep. You're welcome. All right, so that's the insurance company. Life insurance. Let's see what else we have here. There's another life insurance. There's a raffle, roulette wheels. We have sales. It looks like the question that's taken the most time so far is questions number 1 and questions number 3. No doubt, because those are getting started. All right, that's the one we just did right there. Number 14, we just did that one. Oh, this is from a frequency distribution table. So that's nice. We don't have to find the probabilities. The salesperson would like to better understand how to increase their sales. What is their expected commission on a randomly selected sale? The commission times the probability, right? Everybody, the condition times the probability. So the expected value is the commission, which is $0, times the probability, which is 0.2, plus $600 times 0.2. plus $1,200 times 0.3 plus $1,800 times 0.3. In other words, 20% of the time they earn absolutely nothing. All right, so if we do our expected value for this one, we have 1, 2, 3, 4 events. All right. We don't have a table that has 4 events, but we could set it up so that we could have that. If I didn't want to do it for all of my different events, I could come right down here and I could just type it in if I didn't want to set up a whole table, right? I could put in 0 times 0.2 plus 600 times 0.2 plus 1200, whoops, 1200 times 0.3 plus 1800 times 0.3. You can see the expected value is $1,020. All right, everybody, just think about that. If you're in sales and if you knew that you expect to have $1,022 per sale, that's right, we just came up with that. If we know that we expect to have $1,020 per sale, would you just not keep selling, right? Would you not just not get worried if you don't sell, right? So everybody, how do people have courage to keep going when they get a whole bunch of no's? Because they know for every person they talk to, they're going to sell so much money, right? On average. That's what you know. That's how you have confidence. You know, if you do this on average, you're going to keep succeeding, right? If you're a baseball player, if you hit 30% of the time, if you keep swinging, you know you're going to hit. It's going to happen. If you're selling, you know you're going to sell. Whatever you do. This is question number 19. If you know that if you knew that for every sale you made, right, then you'd have to talk to and see right how many, well, this is the probability they sell, so that's it. They know for every person they talk to, they're on average going to win $1,020. This says the salesperson would like to make at least $5,780 in commission this month. Supposing the relative frequency of their commission stays the same, what's the minimum number of sales they would have to make in order to achieve their goal? How do you guys think we would calculate that? Well, we just said, right? We just said we're trying to find the number of sales. So if I go right here and if I put these in parentheses, and if I want to know how many sales, I could let X equal sales, and I could say that's equal to how much money do I want to make? $5,780. $5,780. If I go over here and look for my value of X, I should look for a green. It's right there. There it is. I have 2 green ones. Which one do I want? That one. All right, that tells me I need to make 6 sales. I need to make 6 sales in order to make $5,780. I need to make 6 sales per week or per month or whatever it is. All right. If I know that I make $1,020 per sale, I know I only have to make 6 sales to make $5,780 a month. If you knew that, why wouldn't you sell some more, right? Why not sell a bunch of them? All right, we have about 19 minutes left in class, so I'm gonna let you guys work on whatever it is you want to work on. Whatever question you're on, go for it. If you want help, I'll be glad to help you. If you have not started it yet, now would be a good time to do so. If you're stuck on the first question and you need my help, just let me know, everybody. Don't be shy, okay? If you're stuck on the first question, I see at least one person is stuck there. We've had 27 attempts and 14 correct. That means it's taking us about 2 attempts per correct answer, right? So what's the probability you're going to get correct on the first one? About 50%, right? That's about what it's going to be. Probability is. If you have questions, now's the time to ask. Don't go away not knowing. On this question number 12, we're looking at comparison. Put them all together in one space, everybody, one right above the other. Don't do them and erase them, do them, erase them, do them one right over top of the other so you can see them all together. Do you guys understand what I'm saying when I say that? To do all three at one time? I'm saying this for this one, for the 4-number square. If you haven't signed attendance yet, everybody, you can do so right now. Okay, number 12. Take the 4-number space. All right. From the standpoint of the player, if the player gains, how much do they gain? A $5 bet on 4 spaces could win you $40. That means you would gain $35. So you would gain 40 minus 5. What's the probability? It's 4 out of 38. All right. If you lose, how much do you lose? $5. What's the probability you lose? That would be 34 out of 38. That's the first one. I would put these all together at one time in my calculator, one over the other. All right, what's the 5? A $5 bet on 5 spaces could win $30. 30 minus 5 times 5 out of 38 plus a negative $5. If they lose, they still paid $5, right? And what's the probability? The probability is 33 out of 38. Yeah, sure. You can go, Jenny. That's fine. If you need to go, go ahead for it. Go get rested up. All right. For the 6-number line, if you win $6, if you play, I'm sorry, 6 spaces, you could win $25. That's 25 minus 5 times 6 spaces means I have 6 out of 38. Good night. All right, if I lose $5. And what's the probability of that? It is 32 over 38. Which one of those is the best from the player's perspective? I would put these all 3 in at one time. Everybody, one right over the other. Don't let them get far apart. You want to be able to see them together. All right, so right here, I could say 40 minus 5, and the probability is 4/38. 4/38, and that is negative 5, and that probability is 34 out of 38. All right, you can see that is negative 79 cents. All right, go to the next one. 30 minus 5, the probability is 5 over 38. You lose $5. The probability is 33 divided by 38. All right. The next one is 25 minus 5. The probability is 6 divided by 38. If you lose, you got minus $5. And the probability of that is 32 divided by 38. If I go down here and look, I can see that there are actually 2 of them that are the same. The best one from my perspective is negative 79 cents, right? On average, the first one would only lose me 79 cents. On average, the 5 and the 6 spaces would lose me $1.05. So the best one is the 4 space. The worst 2 are the 5 and 6. Okay, what are the best bets from the standards point, from the bettor's point of view? The 4 space. What are the worst or worst bets? They are the 5 and the 6. What are the best bets from the casino's point of view? 5 and 6. That's where they make the most money. What are the worst bets from the casino's point of view? 4. All right. So you can't possibly know those unless you put these in and put them all in at one time. So you can see them right one above the other, right? Right here. I have them one above the other so that I can see exactly what my answers are.
So I did all of that and followed along, and I'm getting a 58% with the question.
Okay, that means that some of them were missed.
Could potentially the best bets for the casino be all of them since they're negative? And then,
No, 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 they can't all be. It says I did not select all of them. My answer is partially correct, partially correct, partially correct. I got 58% as well. All right, so let's see. Okay, you see what they're saying? They pulled the fast one on us here. What's the fast one? They're not taking the $5 out of the bet. So they're assuming without saying so. They don't say it. You see that? They didn't say so. They said you win 40 bucks. You don't actually win 40 bucks. So they're saying that you get your bet back. That's what they're saying without saying it. So back here in Desmos, I would have to take this out. Let's see how that changes it. If I take that out, if I take that out, and if I take that out. Now it says I have two best bets. They are the 4 and the 6. They're both negative 26 cents. But see, that's why these are tricky. That didn't say so. Anybody see where that says so? It doesn't say you get your $5 back. So they're telling you without saying so that you're actually getting your $5 back, but they didn't say it. That's kind of a sneaky one. I'm glad you made it back, Arlene. So that would be 4 and 6. The worst ones from the bettor's point of view would be 5. With this, the 5 is the worst. From the bettor's point of view, the 5 is the best. The 5 is the best from the casino's point of view. All right. So if you get your $5 back, yes, the 4 and the 6 would be best. The 5 would be worst. So down here, what's the best bet from the casino? The 5. And what's the worst from the casino's point of view? The 4 and the 6. %, correct. So our formulas were all correct. They just pulled a fast one on us. So which question is that? That's number 12. Be on the lookout for number 12, everybody. On number 12, assume they get their money back. Do not assume that they lose their $5. Okay, we got just a couple minutes left for class tonight. If you didn't get signed in before, make sure you get signed in now before you take off. On Wednesday night, we will cover odds and go through and answer any questions that you guys have and prepare for our exam. The exam will be on Monday, and just like before, you'll have the whole class period to take the exam. You have to have your camera on to take the exam. Your exam will be updated for you automatically. You'll know what your grade is on the exam and in the class by time you are finished. How do you guys feel about this unit as compared to the first one? Do you feel better about this one? Is it more stressful, less stressful? Very good, a lot better? We will have more time. Yes, we'll have more time. I'll give you multiple attempts on this one as well. I can tell you. There are 26 questions. And you guys can go anytime you like. It is time to go for the night. So take care, everybody. Have yourselves a great evening. I'll see you all Wednesday night. Thank you, guys.